Good morning, and welcome to the second edition of Ceramic Storytime with Sue for today. So, if you were with me earlier um, at 9 o'clock, I read my blog post, How to Fix a Hard Panned Glaze with Epsom Salts. And so now, because these two blog posts are related, I thought I would do them both on the same day. So this time, I'm going to read my blog post, How to Make a Saturated Epsom Salt Solution to Flocculate Your Glazes. So if you would like to follow along, you can go to bit.ly, that's bit.ly/Epsom Salt Solution, and that will bring you to my blog post. So let me just share my screen here. So that will bring you to this page on my website, and you can follow along. And you can also, if you like, you can also download this blog post as a PDF. So you can just click this link, enter your email address, and then it will send it right to your inbox. So let me just make sure I'm live here before I start reading. And if you are joining me live, please say hello in the comments and let me know where you're joining me from. Looks like I'm live. Okay, cool. I always have to check because technical difficulties happen quite often. So I'm going to get started and talk about how to make a saturated Epsom salt solution to flocculate your glazes. And so if you have any questions as I'm reading, feel free to type them into the comments and then I can answer them live here. So flocculate, what does that even mean? You may have heard this term flocculate in reference to glazes that thought it was a funny word, but you've never really known what it means. Or you may have been told what it means several times and still don't really understand it. Or maybe you understand what it means, but you always mix up flocculate and deflocculate because you can't remember which is which. This sums up my own progression of understanding the word flocculate. I don't know why, but it took me so long to really get it. Nobody ever explained it to me in a way that solidified it in my brain. I made a point to read every article and excerpt I could find about it until I was finally like, oh, now it makes sense. I could write pages on flocculation and deflocculation now. It's a pretty complex subject when you get into the science, details, and nuances of it, but the basic principles are straightforward. Flocculation affects how the clay particles in a glaze recipe interact with each other. This is a very important distinction. Only the clay particles in a glaze are affected by flocculation. So your glaze recipe must first have clay in it, bentonite, kaolin, or ball clay, for flocculation to work. When a glaze is flocculated, the clay particles become attracted to each other and stick together instead of flowing freely past one another. Here's how it works. Clay particles are flat and thin like tiny playing cards. They have flat faces and thin edges. The edges and faces of a clay particle have a charge, positive or negative, like magnets. Positive attracts negative, but two positives or two negatives will repel each other. The faces of a clay particle are negatively charged. The edges can be both negative and positive. So when you add Epsom salts, which is magnesium sulfate, to flocculate a glaze, you're introducing positive magnesium ions to the glaze. These positive ions attach themselves to the edges of the clay particles, so now the edges are all positive. Since the faces have a negative charge and the edges have a positive charge, the clay particles all start attracting each other and sticking together, edge to face, face to edge. So this is an example. So these hexagon shapes are clay particles. And so this shows the faces of the clay particles have a negative charge. And then when you flocculate your glaze, the edges of the clay particle become positive. So the edges are attracted to the faces. So it's like you've got the edge attracting to the face and then the edge attracting to another face. And it's like a house of cards like this. So you've got the edges connected to the faces and it creates this open network. So yeah, this forms an open house of cards-like network of clay particles throughout the glaze bucket. The clay particles are bonded together, but there are lots of open spaces in between them. Oh, hi again, Gemma. Gemma says, hi again, and thank you for these podcasts. No problem. This is fun for me too. So, this open network of clay particles does a few key things. Number one, it increases the viscosity of the glaze, making the glaze thicker in the bucket. Number two, it helps to keep all the other particles suspended in the bucket. And number three, it increases the time it takes for a glaze to dry after applying, promoting a smoother application. So, if you're wondering whether your glaze needs to be flocculated with Epsom salts, consider these three issues. Number one, are you trying to thicken your glaze? So if your glaze is too thin in the bucket, flocculating it will thicken it. Number two, does your glaze need help staying suspended in the bucket? Is your glaze hard panning? So like I described earlier today in the previous post about how to fix a hard panning glaze with Epsom salts, if your glaze is hard panning, then flocculating it is going to help keep all the particles suspended in the bucket. And then number three, is your glaze drying too fast, causing an uneven application layer? So if you're dipping your pots in a glaze and then the glaze dries instantly, or maybe you're brushing your glazes and then the glaze dries as soon as the brush hits the bisque, then those are signs that your glaze might need to be flocculated. And then flocculating will help to help the glaze to take a little bit longer to dry so that it can kind of smooth out and you'll get a nice even layer before the glaze dries. So if your answer to any of these questions is yes, then you may need to flocculate your glaze. So to sum up what flocculation means, a flocculated glaze has clay particles that stick together rather than move freely past each other. A popular way to remember this is the clay particles flock together like sheep flock together. So flocculate. So a flock of sheep, flocculate, they all stick together. We didn't talk about deflocculating in this post, but another mnemonic device that I use to remember the difference between flocculants and deflocculants is that Darvan is a deflocculant and a dispersant, and they all start with D. So when I'm thinking of using Darvan, Darvan is for deflocculating. They both start with D. So that's just like a little trick that I use that my brain likes to, let me just remove this text from the screen here, that my brain likes to use these little tricks to remember things. Whatever it takes to figure this stuff out, right? So read this before flocculating. Flocculating should always come after measuring specific gravity. Measuring specific gravity is a way to calculate whether your glaze has the ideal amount of water for your application method. You must get the water content right before determining whether your glaze needs to be flocculated. If your glaze is too thin or won't stay suspended because it has too much water, then flocculating isn't going to help. In some cases, it will make your glaze application worse. The only way to know whether your glaze has the right amount of water is by measuring specific gravity. It's a quick and easy process that will improve the consistency of your glaze results. If you're not familiar with how to measure specific gravity, you can grab my free guide. If you go to suemcloudceramics.com/SG guide, so SG stands for specific gravity, then I will send you my free guide for how to measure specific gravity. So you can get that all sorted out, and then you can decide whether your glaze needs to be flocculated or not. Measuring specific gravity is the essential first step before you do any flocculating or deflocculating of your glazes. Once you know the water is where you want it, you can ask yourself the 3 questions above to decide if it needs to be flocculated. So, what is a saturated Epsom salt solution? Epsom salts are my flocculant of choice. Other flocculants exist, but Epsom salts are easy for me to find and they work really well. Epsom salts, like the ones you can buy at the drugstore and bathe in, are made of magnesium sulfate. If you live in another part of the world, they might not be called Epsom salts. Using the chemical name magnesium sulfate should help you find them. So here is a close-up digital microscope shot of Epsom salts on a green piece of paper. So you can see these, they're just little salt crystals. So I have a couple of microscopes that I like to take close-up shots of glazes and other things with. So this is what Epsom salts look like up close. To use Epsom salts as a flocculant, the salts need to be dissolved in water. This breaks up the bond between the magnesium and the sulfate, so the magnesium ions are free to attach themselves to the clay particles. A saturated solution is defined as a chemical solution containing the maximum concentration of a solute dissolved in a solvent. Additional solute will not dissolve in a saturated solution. So in our case, the solute is Epsom salts and the solvent is water. So the solute dissolves in the solvent. A saturated Epsom salt solution will have the highest possible number of magnesium ions per volume of water. When you add Epsom salts to water, they'll dissolve and seemingly disappear into the liquid. If you keep adding more salts, they'll continue to dissolve until you reach the saturation point. At this point, no more salts will dissolve and they'll start collecting at the bottom of the container. And that's how you know you have a saturated solution, when you have undissolved salts on the bottom of your container. The reason why we want our Epsom salt solution to be saturated is because we don't want to dilute our glaze with more water. Remember, we've already determined that we have the right amount of water by measuring specific gravity. If our Epsom salt solution is weak, we'll be adding more water than necessary to the glaze. The water is just a medium for carrying the magnesium ions into our glaze bucket so they can attach themselves to the clay particles. We want maximum ions, minimum water. When using the saturated solution to flocculate your glaze, you use the liquid on top and you leave the undissolved salt crystals on the bottom. I keep a labeled container full of saturated Epsom salt solution in my glazing area. If I ever notice there are no crystals on the bottom, I just add more salt to the mixture and stir. So here are the steps for how to make a saturated Epsom salt solution. Number 1, grab a container with a lid that you'll store your saturated Epsom salt solution in. A clear container makes it easy to see if you have undissolved salt crystals on the bottom. Number 2, fill the container with water. Number 3, add Epsom salts and stir. Number 4, watch as you're stirring to see if all the salts are dissolving. Number 5, if all the salts dissolve and disappear, add more salts and repeat. Number 6, once you have a layer of salt sitting on the bottom of your container, you know you have a saturated solution. Number 7, Always check for undissolved salts before flocculating. More salt can dissolve over time. If there aren't any, then add more Epsom salts and stir. Number 8, when flocculating, use the liquid on top and then leave the undissolved salts on the bottom. Now, I always get asked, do I need to use hot water? If you use hot water while creating your saturated solution, the salts will dissolve faster and more salts will dissolve overall. Solubility, or the ability to dissolve, increases with temperature. But when the water temperature comes back down to room temperature, the solubility will decrease and some of the previously dissolved salts will precipitate out of solution, which means they'll turn back into solid, undissolved salts. This is perfectly okay because when we have undissolved salts at the bottom of our container, we know we have a saturated solution. You don't have to use hot water when making your saturated Epsom salt solution, but doing so will speed up the dissolving process. I do recommend using hot water if you're making the solution right before you're going to use it. But then it'll cool over time and it'll be room temperature every other time that you use it. So if you only have cold water to start with, you'll be just fine. What matters more is that you have undissolved salts at the bottom of your container when you go to flocculate your glaze. And that's how you know you have a saturated solution. Have I driven that point home yet? Repeat after me. When you have undissolved salt crystals on the bottom of your container, that's when you know you have a saturated solution. So here is an example of a saturated Epsom salt solution that has recrystallized over time. So all the salts had dissolved, and then this sat in my very cold studio over the winter, and then slowly the Epsom salts recrystallized over time. And so they crystallized and they formed these really large chunks. So normally the Epsom salts are these like tiny little granules. And so it's pretty cool that these large crystals formed over time. And then that will often happen when you have fluctuations with temperature. So if the temperature goes up and down. So in my studio, we have a wood stove, and that's the only source of heat. So often there's a bunch of time that will go by where there's no heat, and then we will spend some time in there, turn the heat on, so then the temperature will go up and then it'll go back down to freezing temperatures sometimes. And so with these fluctuations in temperature, that is what allows these crystals to grow. So how much Epsom salts do you add to the water? You might want to know how much salt to add to a certain amount of water. You might think this would be something that I would weigh out and measure very carefully, but I don't. I just add more than I think I need and stir. If there's undissolved salt on the bottom, I stop. If there isn't, I just add more salt. Since I'm always using it and filling it back up again, and water will continue to evaporate and salt will continue to dissolve and precipitate, I'm pretty cavalier about it. The truth is, it doesn't normally take much Epsom salt solution to flocculate a glaze, so even if it's slightly undersaturated, it will usually give the glaze enough magnesium ions to become flocculated. If you don't like the idea of eyeballing it and would rather measure, then here's what Wikipedia says. So at 0 degrees Celsius, so that is freezing temperature, 26.9 grams of Epsom salts will dissolve in 100 milliliters of water. So, 100 milliliters of water at 0 degrees is just starting to freeze. And then at 20 degrees Celsius, so that's like room temperature, then 35.1 grams of Epsom salts will dissolve in 100 milliliters of water. So you can see that as the temperature of the water goes up, then the solubility increases. So you can dissolve more salt in warmer temperature water than you can in a colder temperature. And then at 100 degrees Celsius, so that's boiling temperature, you can dissolve 50.2 grams of Epsom salts in 100 milliliters of water. So it would be a fun experiment to try it for yourself and verify what Wikipedia says. And I do know that one of my students did this and did verify what Wikipedia says. So thank you, Wikipedia, for these numbers. So if you want to try this yourself, you can start with 100 milliliters, which equals 100 grams of water. So you can weigh out 100 grams of water, and you'll know that you have 100 milliliters of water, because 1 milliliter of water weighs 1 gram. That's a fun fact. And so start with 100 grams of water and 100 grams of dry Epsom salts in 2 separate containers. Take the temperature of the water. Then you can add a spoonful of Epsom salts to the water and stir. If all the salts dissolve, add another spoonful and stir. Once the salts stop dissolving, weigh how much dry salt you have left. Subtract that number from 100, and then you'll know how much Epsom salts you need to make a saturated solution with 100 milliliters of water. So if you do this experiment, I'd love it if you would post your results in the comment section below or into the Facebook group. And there are also some other flocculating videos in the group in the unit section. If you check out the unit section, I've posted a bunch of videos in there about flocculating and deflocculating. So if you want some more information, then you can check in there. And that is the end of this blog post. So if you have any questions, please just type them into the chat, the comment section, and I'd be happy to answer them. And then tomorrow, I'm going to be doing 2 more story times. The first one is about, I forget what order I'm going to do them in. I think the first one's about why I don't recommend using a hydrometer to measure specific gravity. And then the second one will be why I do recommend using a graduated cylinder for measuring specific gravity. So if you want to join me tomorrow, which will be October 3rd at 9 a.m. and 10 a.m. Pacific time in the Facebook group, I'll be reading those blog posts and we'll be talking about specific gravity. And then also, just a quick announcement that I do teach an online course about all of this stuff, specific gravity and flocculation and deflocculation. And the course is called Mastering Glaze Consistency. And I only open up registration a couple times a year. So I'm going to be opening registration for that in a couple of weeks. So it'll be sometime in October, in the second half of October. So I haven't figured out exactly what day yet. But if you want to be on the wait list for when registration opens for that, you can always go to sumacloudceramics.com/mastering glaze consistency. That's the name of the course, and there's a form that you can join the wait list. So if you want to take this further and learn all about how to use specific gravity, flocculating, and my whole system for how to get consistent glaze results, then that might be a good class for you to take. So stay tuned for that. And if I have no questions, then I'm going to let you go, and I will see you tomorrow for more ceramic story time with Sue. So thank you for joining, and we'll see you again soon. Bye.